Hello guys, now I am going you to teach the principle of conservation of momentum for IITs. Now, now you might have heard that momentum is conserved where momentum is conserved when net force equals to 0. Actually, this is the concept of class 11 and 12, not for IITs. For IITs, the concept is momentum is conserved in that direction where net force equal to 0 and not in that direction where net force not equal to 0. Now you might be thinking what's new in this? You will obviously know that momentum will be conserved only in that direction where net force will be 0 and will not be conserved in that direction where net force will not be 0. Actually, the problem is that if students cannot solve this type of question, so I'm going to teach you how to easily solve this type of question. So the question arises is that how to solve it. So let's take that ball of mass m1 having velocity u1 collided with ball of mass m2 having velocity u2. Let's take this angle was theta 1 and this angle is theta 2. Now see that let's take this direction x and this direction y. Now you see that along x direction, actually this is the line joining the centers of two balls. Now see that, and we are taking this direction as we are taking this direction as x direction and this as y direction. Now you see that along x direction this ball will exert and force normal force F on this ball along x direction along the line joining the centers, and F force. According to Newton's third law of motion, this ball will exert equal and opposite force to this ball. Ball M1 is exerting some normal force on ball M2 along positive x direction. According to Newton's third law of motion, ball M2 will exert an equal and opposite force F, which will be acting obviously along negative x direction. So that's why only the force will be equal and opposite. So net force along x direction is F minus F equal to 0. Now you see, for momentum will be conserved along x direction. Now let's take a recap at previous one. At this one, see, this component is m1 given cos theta 1 and its component is m2 u2 cos theta 2, and we are not taking the final. Let's take it also. Let's it be v1 and let it be v2 moving at angle. This is phi 1 and this is phi 2. So its x component is m1 v1 cos phi 1, m1 v1 cos phi 1, and similarly we think that this is m2 v2 cos phi 2, m2 v2 cos phi 2. Okay, and in y direction momentum will not be conserved. Remember, in y direction momentum will not be conserved because there is a friction. If there will be no friction, then only momentum will be conserved. Well, thank you. Hope you enjoyed.